everyone, and thank you for attending today's webinar, Raise Your Battery Attachment Rate with Complete Energy Storage Systems. I'm Billy Lee, Senior Editor with Solar Power World. Before we get started, there are a few things you should know. This webinar will be sent to all registrants, so you may view it again. Slides are available to view at any time via the resource widget on your screen. Submit any questions related to today's webinar in the Q&A window. We will try to answer these during the webcast. If you do not get to your question, our presenters may reach out to you after the broadcast. And finally, if you're watching this on demand, you can still use all of these features. So let's get started with today's webinar, Raise Your Battery Attachment Rate with Complete Energy Storage Systems. Today's speakers are Michael Mendick, Country Manager of USA and Canada at GoodWe USA, Jock Patterson, National Technical Sales Manager at GoodWe USA, Chris Seipel, Vice Chairman of Energy Transition and Power and Renewables at Wood Mackenzie, and Michael Bishop from Technical Sales at LG Energy Solutions. And now I'll turn it over to Chris.
Thank you, Billy. Welcome, everybody, and thank you to GoodWe for inviting me to participate in this webinar and share our views on our outlook for distributed storage. I would like to just I'm going to kick off the first part of the presentation by talking about 2002 and some of the macro level themes that were established in 2002 that we think will have a pretty substantial impact on the storage industry going forward. And then after I've gone through those macro level themes, I will delve more specifically into distributed solar and in attachment to solar projects. So I really do believe that I've been working in the power business for close to 30 years now. And I think 2002 may have been one of the most significant years that we have gone through in this industry. There were a couple critical factors related to our conversation today. The first is, in both Europe and the United States, we have established substantial long-term public policy support for renewables, for storage, and for electrification of the economy. And so I'll talk a little bit more about that and what it means for storage. The second factor is, at the same time that we've kind of established this long-term public policy support, 2002 really just highlighted the challenges that we are having really across the globe, not just in the United States, supplying reliable electric power to households and to businesses. And then, a third interesting factor that we've kind of seen change over the past couple of years, but was really highlighted in 2022, is how the relationship between gas prices and gas demand has changed. And this has implications for power prices, and because it has implications for power prices, it has implications for storage that I think are going to have an influence over the course of the next decade as well. So I'll start by just talking about those three factors. As it relates to the Inflation Reduction Act, I said it puts in place very substantial economic incentives for the long term, something that the renewables and storage industry never had before. And this just for utility scale power, for projects for wind and solar, it gives you a sense of just how steep these reductions are. So something that would typically cost $40 a megawatt hour, depending upon the level of different bonuses that a project is able to achieve, it's going to result in anywhere from a 20% reduction in cost to a 50% reduction in cost. And this is similar for, if you were to make a graphic for storage, it's similar for storage as well. And this just makes renewables much more competitive in the marketplace. And in particular, the reductions in utility scale solar costs have some pretty material implications for the storage industry that I want to come back to in a second. Now, for some reason, when I push the button, it is not switching to the next slide. I don't know if somebody else can hit the button and get it to switch to the next slide.
The button did slide if you're looking for policy support for renewables forecast to last to 2040.
Thank you. I did that or somebody else. Sorry about that. So a lot of people, when they talk about the Inflation Reduction Act, they talk about it being, essentially subsidies are being put in place for 10 years. But the way the legislation actually works is the production tax credits and investment tax credits for solar and for storage and for wind will be in place until the later of 2032, or whenever we achieve 25% of 2022 emissions levels. Even with a substantial scaling of the renewables and storage industry, we don't see the U.S. hitting 25% of 2020 emissions levels until the mid 2040s. So we're expecting that these subsidies are going to be in place for almost the next 20 years, and this gives you a sense of this is our projection of utility scale solar, storage, and wind additions, and you can see the industry scaling from roughly a little bit more than 20 gigawatts a year right now to to almost 80 gigawatts a year by the time that we get to the end of the decade. And another important factor is that you see that in a lot of markets, it is solar, along with storage, that is becoming the most economic new addition to the grid. And so a lot of these additions we are projecting will be solar and storage. And one factor, I said I wanted to kind of come back to the implications of all of this for storage. One part of the bill that was very important to storage was that it gave storage the option to get a standalone investment tax credit. No longer has to be tied to solar. Another important change is that it gave solar facilities the option to elect for a production tax credit instead of an investment tax credit. And there's a lot of complication involved with this, but in general, particularly for solar projects that are in the southern part of the United States that has higher capacity factors, the production tax credit is a lot more competitive than what the investment tax credit is. And so we expect to see, more and more solar projects opting to go forward with a production tax credit. And the implication of this for storage is that, if you have an investment tax credit, you're never going to bid lower than $0 a megawatt hour to sell power into the grid because you would lose money. But if you're going to get a production tax credit, you're going to be willing to bid as negative as the value that you get from a production tax credit. So you would be, if you're getting a $28 megawatt hour production tax credit, you're going to be willing to bid up to negative $28 a megawatt hour into the grid. And because we're adding so much storage and wind over the course of the next decade, and a lot of this solar and wind is going to have production tax credits, we are forecasting that wholesale power markets, even with the utility scale storage additions that are happening, are going to have a lot of negative price hours in the market. And so you can see by 2030, we're projecting that 10% of the hours in California will be negative priced hours, meaning that an owner of a storage asset, if their rates were somehow connected to wholesale power prices, would be getting paid to consume power from the grid. Places like Texas, 14% of the hours are negative. And this is, this is already taking into account the amount of storage that we're forecasting is going to get added to the grid. And the reason I just point this out is that I think this is going to create a new conversation that we really haven't had, historically, even in looking at distributed storage, around, how do utilities deal with all of these negative pricing hours, and how do we need to look at rate design issues so we can kind of mitigate the consequences of negative price hours in the market and optimize the system as a whole. So these are some of the really kind of important factors from the Inflation Reduction Act that are going to have an impact and kind of shape the storage market over the course of the next decade. Now, another factor that also relates to wholesale power markets is how the composition of supply is changing within wholesale power markets. And as you can see, and if you look at the graphs in front of you, and you focus on the red part of the curve, you can see that the share of natural gas in the market has been expanding. You can see that the share of wind has been expanding. You can see the share of solar has been expanding. And these technologies are all kind of capturing additional market share at the expense of coal, essentially, and to some extent nuclear generation as well. And if you look at 2022, 2027, 2032, you can see that we are increasingly moving to a system in which the only form of controllable, dispatchable generation is natural gas. And this is true in the US, this is true in Europe, this is true in Japan. And what we're seeing that means is that, if you look at, there's three lines in this graph. If you focus on the one that says years 2017 to 2020, you can see that from 2017 to 2020, whenever gas prices went up, you also saw gas demand go down. So this was kind of like a release valve on gas prices. If gas prices rose too high, you would just see gas demand go down, and that would kind of cap the level of price rises that we would see in the marketplace. If you look at the graph or the line that says year 2021, and you look at year 2021 high prices, what you can see is that in 2021, when prices rose to above $3, $4, $5 a million BTU, even up to $6 a million BTU, we didn't get that reduction in demand anymore. And that's because we have increasingly less generation resources to be able to move to. And if you look at it for 2022, which is all those purple dots, you can see the prices rose as high as $9 a million BTU. And once again, we did not see gas demand go down in a corresponding way. So we don't have that release valve there in the marketplace anymore. Now, what our gas team would tell you is that there are enormous amounts of, are very ample amounts of natural gas supply available that could be produced, in a range of $3.50 to $4 a million BTU. And so they would say that over the long term, that is kind of where we expect gas prices to be. But the reality is, whenever there's a shock to the system, take like Winter Storm Uri, when that came through, resulting in the Texas crises, we had low wind output levels across the entire continental United States for almost 11 days. That would be a shock to the system. When a shock comes through like that, and we have to call on increasing amounts of natural gas, we don't have that same kind of release valve there to mitigate the level of price increases. And so over the course of the next decade, it is likely that our overall experience will be, a fair amount of volatility in natural gas prices. And because natural gas prices have a large influence on power prices, that means that we will have volatility in power prices. So one of the factors that has contributed to the increased attachment rates that we've seen for distributed solar paired with storage is the higher electricity prices that we have experienced in 2022 as a result of these gas prices. And that type of volatility, is likely to be, another factor that is kind of driving the move for installation of storage systems. Not necessarily sustained retail price increases, but more the year-to-year volatility in electricity rates. And this is also a factor. This type of volatility in the marketplace also makes storage more valuable overall as well. So the last factor that I would like to touch upon as it relates to kind of the macro trends is the extreme weather events that we have seen across the globe resulting in power outages. And, it's actually, sadly, a challenge to keep this updated just because there are so many frequent events. So, in Canada, there was a powerful derecho storm that triggered widespread blackout across Ontario and Quebec. Over the past couple of years, we've had the wildfires happening in California, resulting in brownouts. We had the Texas freeze. We don't have on here the hurricane that hit Florida recently that caused outages. And I am located out of Boston, but today I am working in our Louisville, Kentucky office, where we have a number of employees who have not had power over the weekend. One of them did not get power back today because of a severe windstorm that came through the state on Friday. And if you just look at kind of the questions around the resiliency of the system, I mean, in Europe, the Europe crisis has largely been driven by a curtailment of gas supplies from Russia, but there's also extreme drought and heat in Europe this year. We had to reduce the amount of capacity. We had nuclear power plants because there wasn't enough cooling water to cool the power plants safely. It became difficult to get barges down rivers to be able to get coal supply there. It caused, the peak demand due to the high temperatures caused an outage in Italy. And, this resiliency challenge for the grid is not happening because we are introducing variable renewables into the system at this point. This is really kind of the resiliency of the grid as it relates to dealing with severe weather. And so this is kind of another one of the macro factors that is, really driving our outlook for storage and is a driver today of why you are seeing residential customers want to have storage installed when they're putting solar systems in. And, and I would also add to this that, a big part of the decarbonization strategy of governments is electrification of heating and electrification of transport, and which just means that we are powering more and more of our economy with electricity. So at the same time that we are finding that we have a more fragile grid, the value of reliability to customers is also increasing. And this is part of what makes us kind of, bullish on our outlook for the storage industry. So moving to some of the more micro level factors that influence our storage outlook, given that California is really the leader in terms of solar and storage additions, whatever happens in California is very important to follow and has big consequences for the industry. Sometimes it sets precedents for what other states will follow as well. And so, there has been a debate about net metering rules, and you see on this graph a lot of different data. This is showing you for Pacific Gas and Electric and for Southern California Edison, the payback period for a solar or solar paired with storage installation at a residential level under the existing rules, which are NEM 2.0, the original proposal for NEM 3.0, the latest proposal for NEM 3.0. And what you can see here is that the changes in the net metering rules, in particular, setting an export rate for selling back into the grid that is a lot lower than what it has been under NEM 2.0, overall reduces the attractiveness of solar installations at a residential level. So we estimate the payback period for a solar installation was 4.9 years. in PG&E's system under NEM 2.0, and it will almost double to 8.5 years under NEM 3.0. Similarly for SCE, it goes from a payback period of 6.3 to a payback period of 10.7 for standalone solar. But what I want to point out here in the context of solar plus storage and pairing with storage is that these changes make storage, pairing with storage, much more attractive than they were previously under the prior system, because the value of when you sell back is differentiated. And so if you're able to sell back at times that not all of the solar is on the, producing on the system, you're able to save some of that, sell it back later. You're able to reduce your payback period. This is particularly true in the case of Southern California Edison, where we estimate that instead of having standalone solar, if you have solar plus storage, you will have a payback period of 7.5 years rather than 10.7 years. So while we see this NEM 3.0 overall reducing our outlook for distributed solar, we see it increasing our outlook for storage attachment rates. So the future looks very positive for residential storage installations. So does the but that is just a continuation of kind of the upward trend that we have been on. I think overall distributed storage additions in 2022 were 40% higher than what they were in 2021. You can see that California remains the leader in terms of overall installations, although its share of the market is falling. Its share was roughly 38% of storage additions in Q4 2022. In this most recent quarter, we estimate it was, approximately around 50% of the additions. And you can see, the other leaders, Puerto Rico, Texas, Hawaii, Florida in particular. Moving forward to the outlook, this shows you our forecasts for distributed solar plus, this shows you our forecast for storage additions. And you can see that, we're going from roughly 600 gigawatts in 2022 of residential capacity paired with storage to, almost 4 times that level by the time we get to 2027. So a very high growth rate. So this forecast is very closely tied to our overall outlook for distributed solar. So our distributed solar forecast is going from roughly 6 gigawatts in 2020 to around 7.7 gigawatts in 2027. And, the key assumptions driving this are, the continuation of the investment tax credit, growing U.S. module manufacturing capacity such that those bottlenecks don't exist anymore or aren't as extreme, and the state level or utility programs that are in place today playing out as they are currently structured, but not any real new significant programs going forward. So as you can see from this graph, the dark blue line is showing you our forecast for the percentage of residential solar capacity that we think will be paired with storage. And you can see it's growing really sharply from 2022 into 2023. And, and a big driver of this is what's happening in California, which is a large portion of the market, where we think we will see, solar additions go down slightly, but we will see solar, the rate of pairing go up due to the factors that I described. And, a lot of this is also just driven by continuation of state policies like Massachusetts Renewable Target and Connected Solutions Program. New York and New Jersey, we think, are also poised for growth in solar paired with storage, given some of the recent announcements that we have seen there for expansion of programs that they have and setting new targets for the amount of storage capacity that they want to see added to the grid overall. And, in terms of this forecast, California remains the largest opportunity, but Puerto Rico, Texas, Florida, as well as the other states that I mentioned are all growing markets as well. And there's just one final factor that I would add to this. Another driver being that we are also seeing kind of, I guess, what I would call the takeoff of distributed energy resources like solar plus storage actually being able to get some value providing grid services as well. And a few examples of that were Puerto Rico awarding Sunrun a 17 megawatt virtual power plant contract. Sacramento Municipal Utility District has recently launched something called My Energy Optimizer Partner, which will give them anywhere from 10 megawatts to 27 megawatts of solar paired with storage as a distributed energy resource that they're able to control during emergency events. And again, kind of California is the leader in this. We estimate that right now, about 40% of all virtual power plants that incorporate distributed storage are California-based. But this will be another factor that's kind of driving the increased value of an increase in attachment rates for storage with solar. And I think that concludes my remarks.
Yep. Yeah, hello everyone. I'm Michael Mendick, the Country Manager for GoodWeek. Chris, thank you very much for this really great analysis. I really appreciate that. Let me explain a little bit who GoodWe is. So we are an inverter and battery manufacturer focusing now on smart solutions. We started in 2010 and came to the stock market in 2020. We have grown our market share globally up to and over 50% in some regions, and that really made us one of the top 5 global inverter companies. We're expanding production capability up to 30 gigawatt regarding inverters and 2 gigawatt hours for batteries. We are 4,600 employees strong with 800 just in R&D and 150 plus in the global sales force. And some of those is our team in the US here. We have a headquarters in Suzhou in China. We started the subsidiary here in the US last year and have grown the residential part and the storage part. That's what we're really interested in, and also going into the C&I space. Here, a little bit look at the world. We are global. We have 10 branches all over different markets that are differently impacted by storage demand. We see a huge demand in Europe at this point in time. So we're spread out between Australia, Spain, and Portugal. And we have multiple sales and service centers and 4 major R&D centers where we're developing everything on our own hardware and software and firmware. All that is our own development. Let me go to the next slide. So in the past 5 years, we received 9 global awards ranging from product design to supply and financial performance. And in 2021, we were recognized as the most financially stable inverter company by Bloomberg. And so we are here to stay. A quick overview what our products are before we have a little bit of deep dive into storage. Our products range from residential, hybrid, C&I, and utility scale inverters. And recently we launched solar shingles in another region. That's why we want to become really a true solutions provider. Well, thank you so much. And I will pass this on Jock Patterson. Thank you.
Thank you, Michael. So I'll be talking about GoodWe's current and upcoming solutions to meet the increasing demand for affordable, reliable, and smart energy storage systems. As Chris illustrated, there are basically 2 types of driving forces that are going to lead to the increased battery attachment to existing and new PV systems. I describe these in the carrot and stick categories, as the sticks being severe weather, an aging grid, and power price volatility. but the carrot being the US and state public policy that's providing long-term incentives. This is all nice academic conversation, but what does it boil down to the homeowner as? Well, displaying here are the 4 topics that you would likely bring up with the homeowner. So we've got the homeowner wanting security and comfort. Backup power provides that. They also want to have solar savings when they have to deal with a time of use tariff. By having a storage system, you can avoid the peak period charges. And for self-consumption, there's the aspect of being green. So you can be green in terms of environmentally, feeling good that you're consuming your clean energy and not getting the mix of wherever it came from when the utility provided it. You know you're consuming green energy, but you also get the savings of not having to use the utilities energy, which costs more than what you would have pushed back in a scenario where they don't give you pure net metering retail rates. And finally, demand response, where you can actually leverage your investment and have your battery system, your storage system, your ESS, feed into the grid, or at least be available for the grid certain hours of the day. Those would be the peak grid times. So these are the ways that we can talk about the value of an energy storage system for a homeowner. I'm going to talk about our current solutions, and then we'll go on to what's coming down, upcoming this year. So for storage inverters, and inverter being the main part of the system here, we have 2 types, a hybrid inverter for DC coupling and a battery-only inverter for AC coupling. The key thing about a hybrid inverter on the PV side is that it should have all the good technical input characteristics of a regular PV inverter and not lose those when you create a hybrid. And that's the case with our AES hybrid inverter. Both inverters cover the same power class range from 5 to 9.6 kilowatts. I'm going to show you a variety of configurations you can do with this. The object in the lower right is an auto transformer. So if you're going to do backup, you're going to need that device to derive the neutral to provide power to 120 volt circuits. However, if you're only using the system for self-consumption and time of use arbitrage, so to speak, temporal arbitrage, then you don't necessarily need that. But it's not much of a additional add-on cost. So most people would want to go ahead and get that, even if backup isn't their main concern. In this illustration, we're seeing a partial backup, meaning that, and I'll try to bring a pen out here. Unable to get the pen to load up, but that's okay. I'm just going to talk in the center bottom of your screen is an essential load subpanel, and that's where our backup circuit is. So when we lose the grid, we are no longer supplying to the main service panel. We are only supplying backup power to the essential loads panel. This is the easiest type system to set up, and this generation is designed for this type of setup because it can switch over from the grid to the backup to feed your essential loads in less than 10 milliseconds. So that transfer time results in usually no observance by the homeowner because it's so quick. The beauty of the DC coupling is that the solar power comes right into the inverter and can feed right into the battery system. So it's high efficiency. These are high voltage batteries, and we're going to be looking at the LG Resu Prime in a couple slides. But with this high voltage direct connection, we have high efficiency, and this is really good when you're self-consuming. You're getting the most energy you can out of your PV system to store and use later. Here's an AC coupling version where we have our ESS add-on, to an existing PV system on the right. Now, the downside of this design is that if the utility power is lost, the PV system on the right is going to shut down, and you're not going to be able to feed the PV power into loads and into the battery. So when doing this kind of setup, it behooves you to actually move the PV breaker over to the essential loads panel, and that way it stays up, and this becomes a microgrid type system where the solar power coming from a different system feeds back through and up into the battery inverter, which can then store it into the batteries themselves. If we want to do a full house backup or whole home backup, you'll need another device that is essentially an automatic transfer switch. GoodWe has their own. We call it the ATD, automatic transfer device, available for 200 and 100 amp panels. With this device added in, now we can see when we lose the grid, the system will disconnect from the grid physically. So all the power it produces from the solar and what is stored in the Resu Prime batteries can go in and feed the main panel. There is no essential loads panel, so we're doing a whole home backup. In order to drive the 120 volt circuits, you're going to need to have the auto transformer again for this backup purposes. The nice thing is if you're doing whole home, you tend to want more capacity, and that could be both in the form of more energy if you have longer blackouts, or you just have higher power needs. So we allow you to connect to 2 LG Resu Prime batteries. In the situation where you have an existing PV system again, you can do a whole home backup. This time you do not have to move the PV system because the main panel is always being served power, always being provided in AC waveform to keep the solar inverter going up. And if the solar inverter is creating too much energy, there is controls, frequency, watt in the inverter to make sure that the solar inverter doesn't overpower the loads and battery. So what's coming up next for GoodWe? Well, you take what you saw there, and now you see a slightly sleeker inverter. Its key characteristics are that it has an 11.4 kilowatt power class instead of just 9.6. It's designed to deal with the latest modules, right? Our new modules are coming out with greater power. They're larger, but what's particularly increasing is the amount of current on the PV inputs. So this inverter allows 16 amps per string. If you are going to backup mode and you have high surge, high inrush type devices, this inverter has a greater capacity to deal with inrush currents. You no longer see an auto transformer for backup of 120 volt circuits because inside there's electronically derived a neutral to provide the 120. As an option, you can also get the version of this that has a EV charger board and cable to provide 9.6 kilowatts of power. So if you had a 5, a 6, a 7.6 kilowatt inverter, if you want to take power from wherever it can come from, solar plus grid, this inverter will bypass the normal circuitry and provide you 9.6 kilowatts of car charging power, even just in a 5 kilowatt inverter. When you want to do backup, you need a backup device, and we have 2 choices, a regular one for a single inverter, or if you're doing multiple inverters, we have a multiple parallel device. That way you can do lots of LG Resu Prime for lots of power and capacity, energy capacity. So up to 3. So in summary, the next generation is going to offer you a lot of new features, these enhancements, more power. We won't have 2 AC output circuits, that is an on-grid and a backup. It'll be one that will switch roles. No auto transformer needed. We derive the neutral. There is ability to do essential loads backup, but the new generation is designed for a whole home backup. We have the EV charger option, and we can do up to 3 storage inverters and then multiple batteries with each of those. There are no external fans to have to do maintenance on. It's all cooling versus via natural convection. The wiring compartment's easier to work in because it's larger, and you have better insight into how an AC coupled PV system is doing with additional CTs as an option into seeing how that's performing. As far as monitoring, you'll have the choice between Wi-Fi, 4G, and LAN connections. No more of these dongles you plug in. It's built in, and there are other options or features like a dry generator contact, the ability to communicate by the utility, control the system via SunSpec 2030.5 communication, and other more minor details. We do have one other feature we want to mention here is that wouldn't it be nice, if I'm talking to any distributors, if you had a single SKU that can be converted to another SKU in a sense. So imagine the homeowner buys an inverter and they're just doing a PV system, but later they want to upgrade to a energy storage system. They can do that with an access code they get by purchasing the additional feature of energy storage. So they buy it as a PV inverter at a PV inverter cost, but then pay later on if they decide to get storage, an access code upgrade to a energy storage system. And that's just filling in the graphics, but that's it for me. Who's next?
Hi, everybody. I'm Michael Bishop. I'm with LG Energy Solution. I'd first like to thank Solar Power World and GoodWe, our partners, for our chance to tell you a little bit more about our company, LG Energy Solution, and the Resi Prime home battery. So why should you choose LG Energy Solution? Well, firstly, LG Energy Solution was founded as a chemical company, LG Chem, back in 1947. In September 2020, LG Chem was announced that it would spin off its battery manufacturing business as LG Energy Solution, which is the company you're speaking with today. And we are a battery manufacturing business. That is what we do. You can see here that LG has a long history of related technological experience and expertise with electrical chemical technologies like lithium ion and lithium ion batteries. Which means that LG Energy Solution as your battery, when you choose us as your battery manufacturer, you can rest assured knowing that we will be there for you when you need us the most. Here are some of our locations across the globe. We are a global battery manufacturer with worldwide production. The headquarters are located in Korea, along with the main plants and main research and development centers. As for domestic facilities, LG Energy Solution is established in both Ohio and Michigan. And we've recently invested $1.4 billion in Arizona to build a new battery factory to be completed by 2024, as well as another factory in Ohio, which will be completed by 2025. We actually just broke ground on that last week. So it's a pretty exciting time for us at LG Energy Solution. My slides are a little bit messed up before, and my notes. So I actually said this before, but our history here. We were founded as LG Chem back in 1947, and we broke off in 2020. So LG Energy Solution, the battery manufacturer, we are our own company, and that's what we do. We manufacture batteries. Because of our long history, LG Energy Solution is the subject matter expert on batteries, and we've led the global battery market by supplying batteries throughout all market segments, IT and mobility, advanced automotive customers, ESS customers. We are just battery experts. That's what we do. Some of the things that set us apart are battery cell technology. Because we were able to manufacture our own cells, we use our proprietary technology. This includes our lamination and stacking technique. During normal use, the materials inside of a traditional battery inevitably expand and contract. This can cause distortions inside the cell and can lead to problems such as shortened battery life. However, LG Energy Solution uses our lamination and stacking process to manufacture our cells, where components within the cell are neatly stacked on top of each other, which reduces distortion during normal use. This kind of innovative cell technology has been proven to be the most dense and sustainable cell after 500 cycles, which matters when considering a home backup battery. LG Energy Solutions battery cells perform the best over the life of your system because they're the most efficient. And that brings us to our battery. You're looking here at the LG Resu 16H. The Resu Prime 16H is one of the largest home batteries on the market with a capacity of 16 kilowatt hours and is rated for 7 kilowatts of power, 11 kilowatts at peak. The Resu Prime 16H and 10H, a different capacity, can be stacked in parallel to not only double your capacity, for instance, stacking two 16Hs for 32 kilowatt hours, but also stacking will provide more power. You can get up to 11.4 kilowatts with two 16H in parallel, which is up from the standard 7 kilowatts rated with a standalone battery. So high capacity, high power. This is what we're able to bring to the marketplace. And this is our LG Resu 10. Same battery cells, same technology, just a different capacity. This is rated at 5 kilowatts of power, 7 kilowatts peak. Though, when you stack these, two 10H stacked will provide up to 10 kilowatts of power. And that's up from the 5. So you can get up to 20 kilowatt hours and 10 kilowatts of power out of two LG Resu 10H. Some of the key features with the LG, with our Resu Prime batteries, it can be divided into just a few separate pieces. A battery control unit, which rests on top. You can see there. Two battery modules, they're about 90 pounds each. And then the connector plate. It's very simple. The unique modular design means that only one or two installers are needed for installation and maintenance, and which provides for easier transportation and handling. The detachable control unit on top also allows for on-the-spot maintenance and easy replacement, saving time and cutting costs and reducing truck rolls. As an ex-installer, then that's definitely something that I appreciate with this battery, is its modular conformity here. I also want to introduce LG Energy Solutions Global ESS Customer Portal app. Our GECP mobile app offers several advantages over the traditional call center. You can instantly file your claim from any mobile device. You'll spend less time reporting and filling out forms. Fields that require input are reduced in half. You can get real-time updates on the status of your service, and you can track those changes in the app, and it'll be updated in real time. You can find the GC app right now in both the Google Play and the Apple App Store. So I think I busted that. I went through that pretty quickly, but that's a little bit about LG Energy Solution and our LG Resu Prime battery. Again, my name is Michael Bishop, but please feel free to reach out to my cohorts, Andrew and Matthew, if you have any questions or would like to get a hold of us. Thank you so much.
All right, and that looks like the end of our presentation portion, so we're going to open up the floor for some questions from the audience. You can continue to submit those now in the Q&A window on your screen. What we have on deck on NEM 3.0, if I have solar on my new home and a true up bill from PG&E, the public utility, how much solar do I need to eliminate that true up bill with PG&E? What offset do I size the add-on system at? What if I had storage battery?
I'll take that question, Billy. Jock here. So this is a good specific question that I can give a general answer to because there are a lot of details on the input to come with the appropriate output. And this is why solar installers, quoters, integrators, they rely on software because we have to look at the irradiance you get, how much shade you have, the angle of the point of array, which is the angle orientation of your modules, and then what your utility rate is, and the estimated change in your utility rate, and what your current consumption is, and when you consume. And if you're going to get an add-on or EV vehicle, the amount of variables starts really increasing. And that's why this is best done with a tool to factor all these in. And then you can change the inputs as you consider different scenarios. So your installer should be able to access these kind of tools that are available in the marketplace to get you a proper answer. There isn't one answer for everybody.
Yeah, I can just add on to that in general terms, switching from NEM 2.0 to NEM 3.0, the overall incentives are to have a smaller size system than what you would have under NEM 2.0. NEM 2.0, you would want to oversize the system and offset all of the consumption that you're kind of saying, so that you are, because the rates that you were getting for selling back into the grid were relatively attractive. With the lower rates overall, most homeowners are going to be better off going with a smaller size than what they would have been under NEM 2.0. And it's really about, then the really complicated part is, in addition to everything that was just said, figuring out like the optimal size storage system given the export rates.
Yeah, I want to add back that the question assumes a true-up bill on NEM 3.0. Well, NEM 3.0 is really no longer net metering, it's net billing, and you'll be getting a monthly bill. You can't skip that one now. So even the cash flow dynamics change when you go to NEM 3.
I think that's all the time we have today. If you have additional unanswered questions, please feel free to contact our presenters on your own. This webinar will be shared with all registrants, so you may view it again at your convenience. I'd like to thank all of our speakers for being here, and of course, GoodWe for sponsoring today's webinar. And thank you to everyone in our audience for participating. I hope you enjoyed our presentation, and we invite you to join us for more Solar Power World webinars in the future. Thanks, everyone.